graph of f prime, the derivative of f, consists of two line segments and the semicircle is shown in the figure. Does f have a relative minimum, a relative maximum, or neither at x equals 6? Give a reason for your answer.
Okay, x equals 6. Go ahead and put a dot there. And this is going to be very crucial for part D, I believe. So this graph is f prime. It is not the f graph. And we're wanting to know if the original f has a relative minimum, maximum, or neither at x equals 6. So at x equals 6, are we changing directions? Yeah? So let's see. We have relative minimum, maximum happens when we're changing sign. Changing f prime is changing sign. Are we changing sign here at all? Are we going to negative to positive, positive to negative? Nope. But then instead, if f prime is changing directions, the original graph has a point of inflection. So what we're going to say on this one is, it is neither. Sorry, I have to flip back and forth. It'll be neither, because f prime does not change signs. Does not change signs at x equals 6. And that will give you 1 point. Not that the next part matters. You could also write on here, but at x equals 6 is a point of inflection. Because it's changing, oh, I can't say it. F prime is changing directions. That would be a good point to kind of make. But you don't have to. This is all you need, but I want you to learn more out of it. Yes, ma'am?
What if we wrote neither and then said the point of inflection part? Would that seem helpful?
I will give it credit. If I were the grader, I will give you credit for that. Okay? So hopefully they're more understanding as to you looking at the double prime. Okay, let's go on to part B. Holland, go ahead and read part B, please.
What of individuals, if any, is the graph of f concave down? Give a reason for your answer.
Where'd I put my card? It's right here. Oh, here it is. So we're looking at concave down. So concave down is going to happen. So original graph is concave up if the graph is going up. It is concave down if the graph is going down. So let's look at where the graph is going down. So our graphs are going down in two different intervals. Here it's going down, and here it's going down. So we'll need one union. So let's write out our answer. We have it at -2 comma where? 0, union, and then what to what? 4 to 6. And just having that interval alone is 1 point. And if you think you're able to do that potentially, just put a check mark next to it. So we can grade as we go, so you don't have to rewatch the video. And then I'm going to use my sentence stem from what they have. I'm going to use the word concave down. Okay, so the graph of f is concave down on the interval. Repeat it again. It's not going to hurt you. Of the following, because f prime is what? Is decreasing. And that reasoning will give you 1 point. Just try not to use it is concave down because it is decreasing. Say the graph is, okay? Or f prime is. Let's go on to the next page. So far, it's kind of stingy on the points. We're looking at 3 points so far. How many points am I okay with for you to get for each FRQ? 4? 4 to 5, okay? If you can get to 4, I'll be happy. I know a lot of you guys can get to like 8, 7, or even 9, which is even better. All right, so let's go on to part C. Zach, let's read.
Find the value of limit from x equals to, or x is approaching 2 6 f of x minus 3x divided by x squared minus 5x plus 6, or show that it does not exist, justify the answer.
So this is going back to like our unit 1. The first thing that we automatically did was we plugged it in. And then if it was 0 over 0, what rule did we use? L'Hopital's rule, okay? So let's go ahead and write in the following. Just in case it's 0 over 0, if y'all remember when I went over the lesson, you had to show the top is equal to 0 and the bottom is equal to 0, not at the same time as a fraction. So let's do the top one. So we have limit as x approaches the 2 of 6 times f of x minus 3x. And then we plug it in. 6 times f of 2 minus 3 times 2. And at the beginning, they gave us something about f of 2. What was f of 2 given? 1. So this really in the end is 6 times 1, which is 6, minus 6, that is 0. Now let's go ahead and test out the bottom part. Limit as x approaches the 2 of the x squared minus 5x plus 6. Let me make sure it's correct. Yep. And then we plug it in. When I do, we get 4 minus 10 plus 6. What does that give us? 0. So testing that separately is going to give you 1 point. That's a freebie. For you, it should automatically be a check, correct? And then we're going to mention, I'm going to use L'Hopital's rule. And just to recall, we derive the top independently, derive the bottom independently. So we have limit as x approaches to 2. So when I'm deriving the top, it's simply f prime of x, 6 times f prime of x. What is the derivative of minus 3x? Just minus 3. Now let's derive the bottom. The bottom is x squared gives me 2x, minus 5x gives me minus 5. Good so far? Okay. Mentioning L'Hopital's rule, you'll get 1 point. Again, that should be a freebie. Hopefully you're putting a check next to it. And then let's plug it in. We have 6 times f prime of 2 minus 3 all over 2 times 2 minus 5. So we know our bottom is negative 1. Look at your graph. Our graph is f prime. So it's saying at 2, what is my value? 0. So we know all that is going to go away. It's going to be simply negative 3 over 1, which is going to give us 3. And they said justify. We did justify it. So from here, they'll give you, the next point is going to come from all this work, including your final answer. What if I did not simplify and left it as negative 3 over 1? It's okay. For FRQs, as long as you plug the values in, you don't have to simplify it. But what if I did up to this? Is that good enough? No. They want to know what is f prime of 2. Can you read off the graph? So you can stop here, you can stop here. Good? Okay, go ahead and put a check as it pertains to you. Okay, now let's read the last part. Addison, letter D.
Find the absolute minimum value of f on the closed interval -2 to 8. Justify your answer.
So for this one, let's kind of see what's happening. If f prime is going from positive to negative versus negative to positive. So I'm going to refer back to my PVA card. If f prime is going from positive to negative, we have a maximum, correct? So we know this one is max. And we know this one is minimum. So let's kind of write out everything on this one. So maximum and minimum happens when f prime is what? Equal to? If I have a maximum, what is my f prime? 0, okay? I'm gonna cross that off. So I'm gonna go ahead and mention something. We're looking for when f prime is equal to 0. Noticing that is gonna give you 1 point. So if we're looking at maximum or minimum, automatically write out f prime must be 0, okay? So any idea in your head, just spell it out. And then we had x equals -1 and 2. X equals -1, x equals 2, I'm also gonna mention x equals 6, because x equals 6 was also 0, and also say the following. At -1 is max, and then we have at 2 it is minimum, and at 6 it was neither. And are we looking for maximum or minimum here? Minimum? I feel like there's from -2. We're looking for minimum, very good. Okay. Now, normally, I will be okay if you say there's a minimum there because we're going from negative to positive. They're not gonna take it because of the word justify. So we have to actually put our t-chart. So let's all make our t-chart. X and f of x. And we are going to test the endpoints. My endpoints were what? -2 all the way to 8. And we also want to test 2, even though we know the 2 is the answer. And this one, we're going to need Fundamental Theorem of Calculus, card number 6. And I'm going to show you this card. You don't have to take it out. We'll need to use this formula. Okay, so let's see how to go about the formula. Let's actually write it down. A to B. We have f prime of x dx. I think if any, this might be the one you might end up not getting all the credit. FB minus f of a. So at the very beginning, they gave us something. They said f of 2 is what? 1. So we're going to use f of 2 at some point. So let's plug in the following. We have the integral from 2 to x, f prime of x dx. So we have f of x minus f of 2. So that formula we're simply mimicking. So our goal is to make this one by itself. So for that to be by itself, we're going to do some algebra. F of x is equal to f of 2 plus, leave that alone, add it, integral from 2 to the x, f prime of x dx. So we have to actually find the area under the curve. So for this one, f of 2 is 1. So let's apply this. The first one is saying, let's go from integral from 2 to -2. And I'm not going to write the whole thing down, but the average, the area. If I go from 2 to -2, is that numerically correct? No. So because we're going backward, everything below is positive, everything above is negative. Are we all good with that? Okay? But we have to start with the intercept of 1, so write equal to 1. So here I go. From here to here, it is base times height divided by 2. So we have 3 times 2 is what? 6. Divided by 2 is? 3. So we have plus 3 because it's below the x-axis and we're going backwards. And then the next one. If I do base times height divided by 2, what would that give me? 2 times 1 divided by 2? 1. And specifically it's negative because we're going backwards. That's going to give me 3. Okay, let's do the other one. We're going 2 to 2. When we go 2 to 2, have I moved any? No, but then we still have the initial, correct? Initial does not move. We have 1. I'm going to circle these. And then for the 8. 8 is going to be kind of interesting. We have 2 to the 8. All right, from 2 to the 8, we have this triangle, which is base times height divided by 2 is 2. Are we good with that one? Yes? Okay. The next one is a little bit awkward because we have a composite figure hiding one of them. So for that one, I will do the rectangle minus semicircle. Our rectangle is how many if we were to count? 8. And then our area is pi r squared. The radius is 2. So if I do 2, it'll give me 4 pi. But I'm 1/2 of it. It'll be 2 pi. So technically it's 2 plus 8 minus 2 pi. So let's fill that in. We start with the 1 because of the initial. Plus 2 plus 8 minus 2 pi. Technically, that would be 11 minus 2 pi. And keep in mind, pi is about 3. That's going to give you a negative answer. So we know this one is going to give me the absolute minimum. So let's write the following. Absolute minimum of f on the interval negative 2 to 8 is f of 2, which is 1. So we're a point system. 1 point. And all that work to justify, which is kind of annoying, is only 1 point.
Right.
So is it okay that we don't test all the points like that and move on to this? I would be. Okay? Someone count and make sure it's 9. 3, 3,